What's up on Fiberglass crew? Today we're working with Rivnuts. Now in the past I've showed you guys videos where I use the tool and how well it bites into the frame or bites into sheet metal and all that kind of fun stuff. They actually have the tools. Actually I got the big one and the small one because I do a lot of metal work, sheet metal work, stuff like that. So I can justify paying the price of, I think they're $60 and $80 for the tool or something like that. I'll drop a link down below in the description so you guys can see what the, if you're interested in looking at the actual tool. Now, reason for this video, not everybody can afford that tool, or not everyone can justify the price of paying for the tool. So I'm going to show you guys how to take a bolt, a stack of washers, or maybe even a thrust bearing, and do it by hand with junk you got laying around the shop. And also, as a little bonus for you, I'm going to include a little fiberglass trick in on this video. It's not, I'm not using the resins, I'm not using the mats, I'm using a piece of sheet of fiberglass and show you guys how to put a rib nut in it. Just like using pop rivets, you can't just put pop rivets in fiberglass and expect it to work. It doesn't work that way because the fibers and the resin and stuff like that, it'll crack it, fracture it, and it won't bite. But there's a little trick to make this work. So if it's the first time you guys landing on PowerAxe YouTube channel, be sure to hit that subscribe button because I do Jeep videos, car videos, motorcycle videos, all kinds of cool DIY stuff to teach you how to do things yourself to save you time and save you money. Now, I'll show you guys the first way of getting this done. I'm using 1/4 inserts for my video today. So I got a 1/4 bolt. Now it's actually easier if you use the proper length bolt. That one's special. Let me set that aside, because then you don't have to make up all this spacing right here. And whenever you set your insert up, you want your bolt to stick out about that far. See right there, sticking just a little bit, because then you've got proper all full engagement of your threads up inside the insert, and you don't risk ripping the threads out because you've only got 2 or 3 threads gripped or something like that. But just in case around the shop you don't have the proper size bolt, I'm just going to do it the hard way for you. So stack you a bunch of washers. Your first one, you want it to be pretty much proper fit for your 1/4, 3/8, whatever size you're using. Stack you a bunch more washers on to take up space if you need to. And again, it would, if you've got the proper length bolt, you won't have to do all this. But I'll do it the hard way to show you guys, hey, things can get done when you improvise. 5/16 nut, stick it on. It needs to slide over it. Slide that and over it. Now this last one's a little bit special. See right there? I've taken a file and cut little cross marks across it. So when I put it in place, what it's going to do is it's going to grip the top of this insert. And also, if you have star washers, those work if you happen to have some. So we're going to screw that down on there, and you can see how much thread engagement I got coming out right there, which is great. You can have a little bit more, but you don't want too little. You don't want your thread engagement to be up inside the insert. Then you're risking pulling the threads out of the insert. One more final step. Anti-seize. Put a little bit on the threads right here. Have the anti-seize on the threads. Whenever you start to screw it in, the pressure that's on the threads, it'll help lubricate them and not gall your insert, especially if you use stainless steel bolts or stainless steel inserts. So now the anti-seize is providing as a lubricant for that to work better. Now if you want to, you can put oil or whatever in between your washers to allow them to slide better. Now let's put this baby in. Push it in place. Take your wrench. You're going to hold this one in place first, the one closest to your insert. Take your socket, put it into your bolt, press against the bolt. You're pressing in this way to make sure it stays flush. Snug it a little bit. I'm going to allow my wrench to drop to rest inside the V channel right here. And there'll come a point you'll feel it get tighter and tighter and tighter, and there'll come a point you feel like, okay, this baby's pretty daggone snug. You don't want to get crazy with it. Now that you got it locked in place, back your bolt out. Now here's the front side of it here. You come over to the back side, you see where it swells up and bites into the metal and becomes a threaded insert locked into the metal. This metal right here is actually a little bit thick for those inserts, because right here where the ribbing is, if you look real close, that textured ribbing, properly installed, it would flare out around the metal a little bit. So these actually need to be a little bit longer reach. But installing this in sheet metal, like fenders and things like that, works out great. You can see here, this is a 3/8/16, which would be actually a great size for this right here, because you see how much the knurling goes past the thickness of the metal. So once it swells up, it would actually make a mushroom kind of around the metal right there. Those 1/4-20s, I would not be afraid to use that at all, because it's still got a good mushroom effect around the outer edge of it, so it did real well. But that up there is probably borderline. This right here is 1/8" material. But stepping up to a bigger size like it's 3/8 would be actually more proper if the job that you're doing meant for you to have a bolt that size. Now let's show you something to make it a little bit easier. What we got here is called a thrust bearing. See right there is bearing surface there, and what it does, your bearing rotation is like this. Instead of a radial bearing, how you've got the center in the middle, you got the race in the middle and the race on the outer side with the ball bearings encased in the middle as a radial. This being a thrust, because it takes pressure, squeezes like this for the bearing surface. So you take off all your washers, leave that washer there, this washer there, and somebody's going to say, hey boy, your bearing's too big. Technically yes, but here's the deal. As long as you keep your bearing centered, you're fine. So therefore you can order one size bearing, and this one bearing right here will work on many different installs. Now if I was only doing 2 or 3 inserts, this would be no big deal. But if I'm doing a whole lot of inserts, I'm going to go to my main tool, because it's so much faster. So now that I'm using that bearing, I can use less of these washers, but keep everything centered. Now I'm going to use that 5/16 nut there. You see right there, there's the one that I've cut and scored. Now, again, how I did that, I held the nut in a pair of vice grips, took the edge of my file and cut grooves in it like this right here. Rotate a little bit, cut groove, rotated, cut grooves. And well, first I did it like this right here to get a rough textured surface on there. Then I come back, cut my grooves in like this, like that, which gives it the ability to bite into the top of that threaded insert. Okay, so we're going to slide this down there with the gripping section up. A little bit of anti-seize. Just be careful with this stuff. It gets everywhere and it's like ridiculous to get off. It only takes a little bit. Take your insert, screw it down. Be sure your radial bearing's pretty well centered. Again, this makes it easier, but it is time consuming. There is a faster way of doing this. You hold that in place there. Get your tools. Hold that there. Make sure my ratchet's going the right direction. Now the insert now is starting to bite. Now as you tighten it, you'll feel it to get a little tighter as you go. And there'll come a point that you're just going to say, that don't feel right, so then you stop. And what I mean by not feeling right, sometimes when you're tightening a bolt, you feel like, hey, I think it doesn't feel like it's about ready to snap. I might ought to stop. Because you feel it stop. It gets really, really tight. and get your bolt out. Now it did take a lot less pressure with the ratchet using that thrust bearing. And as you can see, screws in just fine on both of them. So like I said, this right here was way easier because of using that thrust bearing. But it is a bit more time consuming. Personally, if I was going to be doing several of these things right here, I wouldn't go that route with using the stacked washers. I'd go ahead and get the tool, but the tool is expensive. So if you're not using stuff like this a lot, it doesn't benefit buying the tool. Let me show you guys something. Look real close at the surface right here. You can see where I cut those grooves in the nut where it gripped the top of the insert. Held that in place great. Now what if you're going to put one of the threaded inserts inside something soft like fiberglass? Watch this. Now what if you want to put a Rivnut in a soft material like fiberglass? It's not quite as strong as steel is. Will it work? It can be made work, put it that way. If you put it in or expand it, it'll probably lock in place, but because of the inherent properties of fiberglass, it's going to fracture a little bit because of any of your stress points from your bolts and stuff. It's going to wiggle around a little bit. Eventually, it's going to break loose and want to move. But even with the trick I'm about to show you, don't depend on it to be for strength. It's great for like door panels, dash panels, or stuff like that. But for anything that's going to be kind of real structural, don't do this because it just won't stay. So what's the trick? Body washers. Drill you out a body washer that fits perfectly over top of this right here. I've got maybe a 64th of an inch of clearance right there. That's all I've got. What you want to do is take your flat flange here. It goes through first. The washer goes on the back side. Like that. But to save myself a lot of headache, I'm going to go ahead and use my tool that's made for this. And you see right there the die or the mandrel comes through just a little bit right there. Now being that I'm having to hold the washer in place with one finger, with one hand, and crimp these tools, I'm having to take the other side pressed against my leg. Okay, I can feel it right there. It's biting the washer, so I can turn it loose. And that baby's in there tight. Now the actual tool, what I would do at this point to get the tool out, back right here, simply turn that, and the insert's done. Now this trick right here works great for doing body panels, door panels, dash panels. If you have a dash and you want to make a plate to mount your gauges and you have your bolt to run through, that works great for that because there's not a whole lot of weight involved, not a whole lot of vibration to eventually stress out the fiberglass, and it'll start cracking and turning loose. One thing you got to definitely be careful of is the reach of your insert. I went to a 5/16 because I didn't have enough reach with a 1/4 to get through material thickness here and the washer. But it's locked in there pretty tight. It ain't going nowhere. And if I were doing this to a dash panel, that'd be a great place. That if I had a gauge cluster sitting right here, then I could take, and the gauge cluster came around the corner, I could put some bolts in right there to hold it to the fiberglass panel. You could also make you a set of wrenches to do this. Take you a jump wrench, and like these right here's Pittsburgh from, I think it's Harbor Freight, I believe what these are. This is a 5/16 nut. This is a 1/4 bolt. Notice how it slides all the way through like that? So what you can do is take this nut, insert it into the wrench, and let where I cut those grooves in it right there, let that stick out a little bit, and take your welder, weld that nut to the wrench. Therefore, that'll allow you to have a handle to hold your nutsert in place, or your Rivnut, and you can hold it in place while you get back here with the socket and crank it down. You may lay your washer on top of this right here so the bolt will have something to ride on top of. Also, if you don't have a welder, simply get you some JB weld, cram it down inside here, put your layer of JB weld around that, slide your nut into place, and make sure your surface is sticking out just a little bit like that right there, so your riv nut has something to bite to. Whenever it sets up, then you've made your own tool to where you can make your put in your own riv nuts and not have the expensive tools like I have here. I do a lot of sheet metal work and a lot of fabrication work, so I actually have two different sizes of these. I can justify the price for them. But if you don't do it, if you only do a little bit, this is a quick, easy way to fix it. JB weld this to your wrench. If you're at a 1/4-20 insert, you can drop a 1/4-20 through there with a washer. For instance, take this washer here. If you get a washer that fits, and take your washer, that'll ride on top of the wrench part right here. This is sticking at the bottom. Therefore, your bolt, when you run it through, of course, you gotta have the proper length bolt. Whenever you tighten down your bolt, it'll ride on top of this washer right here. This'll nut coming through will lock on top of the riv nut, lock it in place. So when you tighten down the bolt, it'll pull that riv nut into place and collapse it like it's supposed to. You can make an easy tool out of just a no junk wrench. That's a cool little trick with that fiberglass, isn't it? Just like with pop rivets, whenever you put pop rivets in, you got to put a washer behind it. The front side of the pop rivets has a good flared head on it, so you got a little bit of contact surface for that to work. But the back side, when a pop rivet pulls through, you just got that little ball that pulls through that sleeve, which swells the sleeve out for it to bite. That's not going to work on fiberglass because it'll fracture the glass and it just won't hold. Well, the riv nuts are the same way. Whenever it collapses down, whenever you're cramping it down like that, it's going to fracture that glass. Think about riv nuts, if it swells properly, it's going to swell around the outer, like form a collar around the fiberglass. It may hold for a little bit, but it'll never be the strength that it could be. So you need to put that big washer behind it. You may have to drill it out to fit your riv nut, but put that washer behind it like that, so therefore the swelling of the riv nut bites into the metal and becomes a big fat flange in the back of it to hold in place. That is one of the best ways you can do it. If your riv nut has enough reach through softer materials like fiberglass or plastic or something like that, if it has enough reach, I suggest putting a washer like that on the front side and the back side of the riv nut to spread out that load a little more to keep from the plastic or the fiberglass fracturing. But if you don't have enough reach, the depth of that riv nut going through the material, at least put it on back, because that's where you're going to get the most fracturing from. So if you guys learned a little something from this video, hit me with a thumbs up, subscribe if you haven't, leave me some cool comments down below, and I appreciate you hanging out with me. Peace out. Later, y'all.